All right, section 7.6 gets into another brand new concept. The title is called the base E. And in order to introduce the base E, I'm going to talk to you about banking, which is another big application of exponential equations. In banking, there's a formula for compound interest. And the formula is what's in the green box. You may want to write that formula down. Where A is the total amount of money that you have. P is the principal, or the initial amount of money you put in the bank. R is the interest rate you're getting on your money. T is the time in years. And N is the number of times the interest is compounded per year. That is a formula that is, for a lot of you, when you get into banking or when you have your own finances, you're going to be dealing with. Now, let us suppose that we take the basic situation into account, where your principal is $1, the interest rate is 100%, and T, the time in years, is over 1 year. If I plug all these numbers into that formula, I get an equation that looks like this. My amount is equal to parenthesis 1 plus 1, which is the interest rate, over n to the n power. All right. This is the equation that we are going to graph. So I want you to type that in your graphing calculator. Press y equals, and of course in place of the n's you're going to be using an x. And what I'm going to do is I am going to make a t-table. I have my x value, which is my n's, number of times compounded annually, and y would be the amount. Now, if I look at this particular graph, I'm going to notice when x is 0.5, I get a goofy decimal, but basically it's about 1.7 if I round it. At 1, my y value is 2. At 1.5, my y value is 2.3. At 2, my y value is, about 1.5 should be 2.2 about, and this would be 2.3, and then at 3, I'd get about 2.4. Now, if you kept going, as x approaches infinity, you're going to find out that the y value approaches a certain number, which we will talk about here in just a second. Now, if I was to graph this, 0.5, 1.7, somewhere in here, 1, 2 is about right there, 1.5, 2.2, and then I go to 2, and I get to 2.3. 3 is at about 2.4. And what you're going to notice is this particular graph, if I can draw it well on my smartboard, goes something like this. And it has an asymptote. It's got an asymptote somewhere in here, because that particular graph will not cross that line. Well, this green line's value is 2.71, 828, etc. As x approaches infinity, the y value approaches 2.1878, and it goes on forever. Now, this particular number has a very special name. It is called E. E is just like pi. And I'm going to go forward a screen, so if you need to pause that, go ahead. But E has a value of 2.71828. I think I have that wrong on the prior slide. I'm going to go back here. Yes, I do. This is 2.71828 ... Sorry, I'm going to go back. That's a number you need to memorize. It also has a button on your calculator for E. E is just like pi. It is irrational and goes on forever without repeating. But it is a very important number when you deal with exponential equations, especially banking. E is mostly used for exponential functions, and E is for banking purposes. All right, if you need to pause the video, go ahead and write that down. But that is going to be the special number that we are going to use the rest of Unit 7. All right, now let's graph that function where E is the base. We're going to graph E to the x power. Now, a couple things that you need to know. First of all, when E is the base, it works just like any other exponential function, such as y equals 3 to the x power. Just because it's the value E doesn't change it at all. So what I'm going to do is I'm going to make a t-table for x and for y, just like we've been doing all unit long. And what I'm going to do is I'm going to stick some numbers in there for x. First of all, if x is 0, e to the 0 power is 1. If I stick 1 in there, I get a value of 2.71. If I stick 2 in there, I'll get a value of 7.3. And if I stick negative 1 in there, which is a perfect value that you can use, you get 0.36. And if I stick negative 2 in there, I get 0.13. So if I was to graph that, starting with negative 2, it's down here. Negative 1 would be about 0.3. 0 is at 1. 1 is at 2.71, which is about right there. And 2 is at 7.3, which is about right there. And you're going to notice it looks just like one of our exponential models. It has an asymptote of the line right there. So it works very similarly to what we've already encountered in this unit. And that is the base E and how you use it a little bit as far as exponential equations.